How do we keep our Java applications up to date and secure? Let's find out in this podcast.
Welcome to the Foojay Podcast, all your news about OpenJDK.
Last month I published a Foojay blog post about the risks in systems that are stuck on old or outdated Java versions and got a lot of feedback from developers. Most of them want to move on but get stuck on management decisions, outdated production environments, or one of the many other reasons that keep systems stuck on old Java versions and dependencies. Do you want to bring your system from Java 8 to 23? Did you know that Java 17 already got 13 security releases? And that you can use tools like OpenRewrite to help you to update your code? I talked about all these topics with several visitors of the JFall conference in the Netherlands. Gerrit Grunwald about keeping your systems up to date, Martijn Dashorst about the challenges of upgrading projects, Charl Fasching and Charl Fasching also share their experiences with migrating projects, and Johan Janssen helps you to convince your managers of the importance of upgrading. I also interviewed Jonathan Schneider, the co-founder of Moderne and the creator of OpenRewrite. Let's start with my colleague Gerrit Grunwald. He's a DevRel at Azul who loves Java and talking about it. I asked him about the security risks in outdated Java runtimes and how we can keep our systems up to date.
The problem is that most of you probably know when you download an update, right? You see this security advisories. That means that you always get a list of CVEs that have been fixed with this update, but people don't really read it. So I took the time and then created a chart, and this was for JDK 17, right? Just to say, if you start with JDK 17 general availability, the first version, up to 17.011, then you pile up around 70 CVEs. That means issues, security, vulnerability issues that are open if you don't update your JDK. And if you just use JDK 8 and you stick to the last free available version, I'm not sure about the number, 252 or something. I think it's more than 180 or even more CVEs that are open. That means you provide your application with a JDK or JRE, which has so many open CVEs, you open all the doors, right? It's really dangerous from a security point of view. So
a CVE, what is it? It is a known issue which has a specific problem?
Yeah, so a CVE is a common vulnerability and enumeration. That's what it's called. And the idea behind it is that someone figures out a vulnerability, right, in the JDK, for example, or in whatever software you like. You can read that up. Everything is documented in the so-called NVD, which is the National Vulnerability Database, which if you just search for NVD, you can find all the CVEs there with a description, what is the harm they are doing, and all these kind of things. And like I mentioned, with every update of a JDK, of each of the JDKs, you get a list of fixed CVEs with this update. So that means you can really look it up. I think in the advisories, you can even just click on the CVE. It will lead you directly to the NVD page and then will show you everything about this CVE.
So you mentioned every update. If I'm on version 17, am I safe?
Depends. It depends on the update, right? So we have 4 updates a year. And I think it's January, April, July, and October. Or September? No, October is the update. And so that means every 3 months, there is a new updated version of the JDK and JRE, which contains security fixes, right? So, and this is announced publicly, and you should just go there, download the latest version, update your environment everywhere, right? And to make sure everything is secure. Interestingly, most of the developers don't really update to the latest JDK. They have, I have 17, what is it? 3. Yeah, that's fine. It works. Yeah, it works. But still, it's a good idea to keep it up to date. And there are different tools that help you with that, right? You can use SDKman, for example. We have this Disco API that Foojay created where you can get the latest version of all the different distributions. So that means there's not really a big hurdle to just update the JDK. It's for free, it doesn't take long, but people are lazy. That's the biggest problem, I think.
And that's also the distinction between a long-term support version and a short-term. So 17, 21, they keep being updated, and all these ones in between, that stopped somehow?
Yeah, so the idea is you have it's not really official, right? So, but somehow it is, because there are specific versions of OpenJDK builds that get longer support than others. In the past, there was this name like long-term support version, LTS releases, which Oracle said there is no LTS release, but somehow it is. And it started with 8, then we had 11, 17, and then 21. And that means if you, for example, look from 17 to 21, all the versions in between, that means 18, 19, 20, these versions only get support for 6 months. So you get 2 updates, and that's it. And after that, you have to switch to the next JDK version to be safe again. Because if you, for example, stick to 18, then 1801, 1802, and that's it. There won't be any security fixes for this 1802 version anymore. So that means if there are any vulnerabilities in this version 18, you have to live with it, right? Or you have to update to the next version, which is 19, and then again 1901, 1902, and then it's 20 or 102, and then it's 21. And 21 get updates, I think, up to 2035 or whatever. So that means if you go to production, always make sure you use a long-term supported version. This is the golden rule, right? So, and you have to really do that, because otherwise bad things can happen, right?
Or if you use a short-term version because you really need that new feature, you also have to keep moving to the next short-term until you're back at the long-term.
Which is really, I mean, for small companies or for developers, it's not a big deal, right? You just download the latest version, install it. Okay. Oh, there's a new JDK. Yeah. Okay. You go from 1802 to 19. No problem. For company, totally different story, right? Some companies, it takes really long because the process internally is not so easy to update all the stuff to the next JDK. Again, in case you need a specific feature from an STS, a short-term support version, then you have to update to all the JDKs up to the next LTS, right? So that's really important, but it's a lot of work, right? So this is, and there's even other policies I heard of, which some companies have the policy, they are not allowed to go to the latest long-term support version, but only to the one before, which comes with totally different problems, right? Because, for example, if you, for example, go with an Oracle JDK, which is free, yeah, in production, nice, for 3 years. That means you go to 17 because you are not allowed to go to 21. So then 21 comes out, but this company needs to stay on 17. But as soon as 21 comes out, the license change, right? So suddenly you have to pay for Oracle, which is really a bad thing. So this is stuff you really, I have a session about that because it's really complicated and most people don't know, right? So they say, yeah, it's free. I can use it for free. Yeah, for some time, right? So where, for example, for the Zulu JDKs, we don't have that, right? So you can use Zulu for free, 17, 21, whatever, even in production. But if you would like to have support, you can pay for it. Where with Oracle, they force you to, after 3 years, if you don't go to the latest LTS, you have to buy it, right? So which is, it's a different thing. So, and this is all these things, and other companies do other things, right? I think, I'm not sure if Bellsoft does something similar or other OpenJDK distributions, but as soon as you start paying for support, you have to make sure that you read the license correctly. Yeah.
So one message people should remember is check the version, but check the last number of the version of your Java, right?
Yes, exactly. So check, it's not only the feature version, like 1721, but check the last one, right? 17.0, 11, 12, whatever, right? This is the important number. And then keep it up to date. That's the biggest thing.
And remember to check it every 3 months.
Yes, you should. Oh, there are tools. I wrote tools. Yeah, right. If you're on Mac, you can use JDK Updater. No, I wrote tools because I forget about it, right? So because you have to check, oh, there's a new version available. So I've wrote some tools that just remind me that there is a new version. I can just click a button and download it.
Keeping your Java runtime up to date is one important topic, but keeping your code and dependencies on the latest versions is equally important. OpenRewrite is a tool to help you achieve that. It was created by Jonathan Schneider at Netflix almost 10 years ago. Let's start with the goal of OpenRewrite.
At this point, there's this general concept we have called tech stack liquidity, which is the idea of being able to move from one state to another. And that could be a framework version update, like a Spring Boot 2 to 3, or it could be a Java upgrade, like Java 8 to 21 or 23, whatever the latest version will be. But it could also sometimes be like I'm trying to get off of one vendor API and move to another, or one database to another. And so anything that requires mass code change like that.
And it's based on recipes, right?
Yeah, there's kind of two parts to it. There's the data, which is we call the lossless semantic tree, which is not the text of the code, and not the abstract syntax tree, but the abstract syntax tree with everything the compiler also solves about it. So when it looks at a particular method, it tries to figure out where the declaring type is, where it came from, all the dependencies, all that's captured in the LST, or the lossless semantic tree. And then recipes are programs that iterate over those trees and make modifications to them. Those modifications can then be materialized back to source code to present a diff, essentially.
I saw some demonstrations of this. So if I move from a really old Spring to the latest Spring, it's actually going version by version. I can upgrade my code. That's right?
That's right. So these recipes themselves are compositional. So you can have an individual step like change a method name or upgrade a dependency, but then recipes can have lists of other recipes. So then, of course, it's recipes of recipes of recipes of recipes. And so the way we'll tend to organize this will be like, to migrate to Spring Boot 3.4 now, you have to migrate to Spring Boot 3.3, 3.2, 3.1, 3.0, which involves a Java 17 upgrade, which involves a Java 11 and 8. So like it will cascade like that. And each one of those steps individually is a recipe that can be ran, or you can run the whole bundle all at once.
Mm-hmm. So theoretically, if I am on Java 8, an old Spring, I could move to Java 23, newest Spring, all automated.
That's right. Yeah, that's the goal.
And would that be a good idea to have it fully automated?
I think that's something that we see, just thousands and thousands of occurrences of now. What gets interesting, I think, is the social engineering or the social dynamics around accepting large change like that. And so some people will just be very, what I call yippee-ki-yay, like Wild West, I'll just take it all and, merge it, roll it out. That's my personality. Some people are much more reserved and will want to take one of those individual steps and run it first and get it to production and then go back and run one of the larger pieces. And so it very much depends on the risk tolerance and how much test automation and everything there is in the project accepting the change.
But because, it's a list of recipes that gets executed, you could indeed do one, push your changes, wait for your test result, and then go on to the next one.
And so a very common thing I've seen is like for organizations trying to get to Spring Boot 3, for example, we're just focusing on Spring for a moment, but there's, of course, recipes for Quarkus and Micronaut and a bunch of other things as well. People will sometimes say like, well, let's just get to Java 17 first, even maybe not 21 or 23, just let me get to Java 17 first. You could stay on Spring Boot 2 and get to Java 17. So it's at least a step in the right direction, get it to production, operate it for a little bit, and then come back and run the larger recipe at a later time.
I can imagine that writing these recipes is not that easy. Who does that? Is that your company who does that? Is that the community?
It's mostly community at this point. I think whether it's easy or not very much depends on what's being done. I think at the framework supports a very low-level visitor pattern traversal of the LST and all of its data. And that's being exposed to that level of data requires some, learning about the structure of code. But recipes also encapsulate higher level types of transformations, like change a method name, for example. You could just use a recipe with an option, which is change method name. You just have to specify the target declaring type and the original method name, and then what the new method is. And you don't really need to know anything about the LST to use it. So a lot of large, complicated migrations are assembled from these building blocks that have been provided at higher and higher levels of encapsulation over time.
So it's a tool which is free available. It's an open source project. So what is Moderne doing as a company on top of this?
Yes, so OpenRewrite is Apache licensed right now, and we think that's essential because the ecosystem is so broad. So recipes should be provided by framework authors as they're making breaking changes. In other words, if you break it, you fix it. That's my mantra. And of course, there's a lot of them, so it requires participation up and down the stack. For Moderne, we provide multi-repository experiences on these kinds of things, which we're going to take a recipe and run it on potentially billions of lines of code, or tens or hundreds of millions of lines of code, thousands of repositories. What's not so obvious, I think, with open source is that recipes, in addition to making changes, can also produce what we call data tables. They can emit structured data out of the LST in rows and columns, so in a tabular form. And so large-scale impact analyses are done at broad scale by writing recipes that extract pieces of information out of the LST. And I'll give you an example of that. We had one customer trying to move from Oracle to Postgres. So, we've all been in situations like this where somebody comes down and says, "Okay, let's move from Oracle to Postgres. Like, how many hours is it going to take? How many engineering resources do you need?" And it's, when you have 4,000 or 5,000 repositories, it's an overwhelming question.
Mm-hmm.
Where is the Oracle specific syntax? I don't even know. So these projects are hard to estimate. What that kind of effort would start by writing a recipe that would just emit every SQL query, rip it apart, look for Oracle specific syntax. And what you wind up with when you run it on all 4,000 repositories is an inventory of where exactly that problem is and what the problem is. And then you can sort of plan that migration. So it's that multi-repository impact analysis and transformation that we really add on top of OpenRewrite.
Okay, so I guess OpenRewrite helps you to evolve your project, while Moderne helps you to keep track of a lot of projects, a lot of different repositories. And so companies
Study them and eventually move them forward,
Yeah. The tool itself, OpenRewrite, is also, I know it exists also in Visual Studio Code as an extension, I think created by Microsoft. Are there other ways or other places where we can find OpenRewrite?
Yeah, so JetBrains also natively integrated OpenRewrite as a plugin, not really as a plugin, but I suppose it's a native plugin. It ships with the IDE now as of this year. Amazon Q-Code Transformers engine, the thing that actually does the work of transformation, is OpenRewrite. Underneath the covers, now just a few weeks ago, Microsoft announced Microsoft GitHub Copilot Upgrade Assistant is also based on OpenRewrite. Broadcom has a product called Broadcom Application Advisor, which is more narrowly focused at Spring upgrades. That's also built on OpenRewrite. So I think we're seeing this kind of broad uptake of this framework as the way of specifying transformations.
Mm-hmm. I think this is the great thing about, as you mentioned, it's open source, so everyone can build these recipes and everyone is responsible to maintain. So is, for instance, the Spring team creating the recipes for Spring?
They do some. I think the Spring team is a bit, they're also trying to productize a commercial offering around Broadcom Application Advisor. So they don't share all the recipes they create back with open source. That's unfortunate. I think, the Micronaut team at Oracle, for example, has created recipes for every breaking change they made for the last 3 or 4 years and open source them. So I think their behavior is a little more commendable, I think, than what we see from the Spring team right now. But everybody has a different position on this. We see the AWS team providing AWS SDK updates in open source, Maven authors, JUnit authors, kind of up and down the language stack. A lot of folks are really providing them back. So the people that provided most of the open source recipes for Spring Boot migration, it was partly Moderne working on it. It was partly some of the large banks we work with. They can't wait for the Spring team to write recipes. They have tens of thousands of apps written on this. So it's been a collaboration, I think, of a lot of different parties that are all hurt in some way by these migrations that have provided them to that large set that exists today.
Which is great. The community just works together to fix these.
Yeah.
As an expert in upgrading and keeping things up to date, how do you look at the problem of companies being stuck on an older Java? What are the advantages of upgrading for such a project?
There's, of course, improvements in the JDK itself, but I was just talking to one of our banking customers executives a few weeks ago. He has a regulator hounding his business unit about one particular vulnerability in in a library, and won't say what the library was, but that library's the minimum fix version that includes that the fix for that vulnerability has a Java 17 baseline now. Now, this whole business unit is right now running on Java 8. And so, my initial thing is, oh, great, we have a Java 8 to 17 recipe. Yeah, but all these applications are running on WebSphere, a WebSphere version that only supports up to Java 8. So you can see how this becomes this like sweater thread pull. Like I just wanted to fix this one vulnerability, but to do that, I have to move to Java 17. And to do that, I have to rebase everything from WebSphere onto Tomcat. And so this is something we'll do with them. It is plannable. It's just that to fix this one thing wasn't just a dependency version bump. It was the whole Java 8 to 17 thing. It was WebSphere Tomcat, which means WebSphere MQ to RabbitMQ, so it becomes a more complex recipe that involves multiple pieces ultimately.
Yeah. So it's not only the Java language or a specific version for the runtime, but it's also the whole system, the production system where it runs on.
Absolutely. So go back to the Spring example. Spring Boot 3, I think, also had a Java 17 baseline. That's not going to run, on this particular application server. So you wind up having to upgrade the whole thing, the whole infrastructure stack as well.
From what I learned myself and from experience from others, the big change is from Java 8 to, let's say, 11, which is then the next LTS. But is it correct that once you've passed that point of 11, things are a lot more smoother and easy?
That was the most dramatic change. That Java X to Jakarta migration was a big deal for a lot of customers. Of course, not all of them use this Java X packages, so it's easier or harder depending on how much that surface area exists in your applications. There are little things, though. I think that there's, for example, a constructor for double, just a regular capital D double box type. The constructor for double has been deprecated and is scheduled for removal. And so you have to move to a static builder now, double that value of. So there's like little things like that. And there can be, in some cases, tens of thousands of occurrences of that throughout the code base. So it's, even small things can be pretty annoying when you're trying to move from one version to another. I love those things too, because something like that, double that value of. We were working with one customer, and that change was proposed, and they actually rejected the whole language version update because of it. They said, I don't like that style. I would prefer to continue to use the double constructor. And so that's like, again, that social engineering problem where we had to educate a little bit and say, I don't like it either, but this is an optional, like it's the constructor's going away. So we don't really have a choice here. And just that little bit of human communication helped to, break down the barrier, that resistance barrier to getting it done.
And like, for instance, for that conversion from double to double value of, is there a single recipe to do that throughout exactly. The whole code? So that could be
and
one.
That would be contained within the larger language version update, but it can be ran in isolation as well.
Yeah, so you can push that one single change across the whole of your code as one commit.
Yeah.
And then, indeed have this fight of, is this an ugly way of writing it or not?
That's right. And that brings up a good point. Some of these things are required, like double that value of is not going to be optional sooner or later. But some things are more idiomatic, like there's a new string.format instance method in Java 17, which looks better in many cases in the code than using the static string.format method that's existed from almost the beginning of Java itself. But, that can dominate the changes. If you do a Java 17 migration, you can have a lot of string.format calls. And so oftentimes people will set that recipe aside, basically remove it from the set, migrate everything else, and then come back and do that in a separate commit so that commit contains just the idiomatic changes to the new string.formatted instance method.
Okay. But it's a nice message that even if you're stuck now, you should really think about how am I getting past this point of where I'm stuck and move on, because one day it will be needed. Yeah.
And that day is coming sooner and sooner. I mean, our applications depend on more and more third-party and open source stuff. It's really an industrialized software development ecosystem, and your supply chain is moving out from under you. So it's keep up, or applications stop functioning sooner or later.
And maybe even there's a bit of cost benefit, because better, newer Java runs smoother, requires less resources, maybe even.
I'm sure I imagine you're talking about this in other blog posts as well, but garbage collection alone is a huge benefit of just moving from Java 8 to 17 if you change nothing else. I think it was something like 30% improvement in just regular G1 collector makes a huge difference.
So maybe a bit of the cost of changing the code is regained by having a better production system.
Which actually leads to another interesting point, that because recipes are programs, they're just regular. It's not like a query language like SQL. It's a program. It's a class. We've seen some interesting situations where people have stitched together online systems or stateful systems with the data at rest, or the code at rest, which is really the lossless semantic tree. So there was one organization just a few weeks ago that wrote a recipe. It was really clever. Wrote a recipe that looked at the Kubernetes manifest in a repository, looked up the application in the monitoring system for the demonstrable usage of like CPU and memory, and then adjusted the resource requests in the Kubernetes manifest to better match what was actually being used in production. And so, afterwards they could actually scale down their Kubernetes nodes, basically just like cut the resources available to them. And the estimated annualized savings was like $5 million or something like that. So you can imagine if you changed nothing else but moved Java 8 to 17 and did something like that, your memory requirements on a cluster like that go down substantially.
So that's what you said in the beginning. It's not just a tool to rewrite your code.
That's right.
It can even help you with your DevOps.
Right.
People who are interested in OpenRewrite, Moderne, where should they start looking at? Are there easy examples with some migration stories how they can test it?
I think if you look at moderne.ai, so it's moderne.ai, at the top of that page, there's 6 key use cases that are fairly common. So security, vulnerability repair, framework migration, et cetera. And those will sooner or later point down to the individual recipe examples that accomplish those things as well.
Martijn Dashorst is a Java developer working on systems used in education in the Netherlands. He has a long history in Java and has a lot of experience with the challenges of upgrading projects.
Well, we constantly monitor, of course, the Java ecosystem, and we upgrade our software. So we started, I think, in Java 5. We migrated to Java 6, Java 7, Java 8. Until recently, we migrated to Java 11. and we're currently on Java 17.
What is the most difficult move from 7.8, 8.11, 11.17? Can you compare that?
We had some unfortunate incidents. I worked also at the primary school system, and we moved from Java 6 to Java 7. And that worked pretty well, but that caused a lot of synchronization issues in our multi-threaded servlet application. So we were constantly waiting on deadlocks in our application, and we tried reproducing it or to try to do performance tests in our own test environments, but we couldn't get the same amount of load our users triggered. So it was constantly, put the version live. Oh, now it hangs on this point. Take a stack dump, find out what the log was, transform that into non-blocking code, and then put the next version live, and until we had all the bottlenecks ready. That was the biggest problem we had with upgrading Java versions. Ever since we learned to first put the Java version, update the Java version for the runtime without changing your code, and then only after that runs very well, modify the source code as well.
That's something people don't realize. So you can run an old version Java on a newer runtime in production.
Yeah.
So that's the first step. Try your application on a newer runtime and then start moving into the code.
Yep, that's what we currently do. So now we're now containerized and such. So you just ship your Java version inside your container. So it's just packaging the new version in your container and then shipping it, and not change your source code, because otherwise you're married to that particular version and you can't go back. One of the things we learned back then is you always need to be able to go back to the prior version. Otherwise, you're hurting your users too much.
Why do you want to move? Is it to make your developers happy that they can use the latest Java? Is it performance? Is it security? What are the main topics there?
All the things. So it's very difficult to get new employees if you're not working with new technology. And I think the Java ecosystem is moving very quickly ahead and improving quite a lot. But performance, every new release or a long-term release gives you better garbage collection, fewer bottlenecks in locking experience, easier to write code, all the kinds of stuff, all the goodies that you enjoy. It's mandatory to upgrade your Java versions, also for security reasons as well. And if you want to keep with the times with the ecosystem, so if you want to enjoy, for instance, Wildfly and new Jakarta EE versions, then you have to move with Wildfly, and Wildfly stopped supporting Java 8 quite a while ago.
With Charl Wanting and Charl Fasching both doing Java development since the early days, I also discussed the approach to keep Java applications up to date. But first I asked them how the current Java is different from the one they started with. Is it still the same language?
Oh, hell no. I started with stuff going back to Orbix, doing some remote client-server type work, and a lot of client-side work, so Swing and the UI framework before that, AWT. So yeah, it's completely different. There weren't Lambdas. There were so many new things now. It's different.
So I started with Java 1.3, and back then it was a lot more verbose, a lot more structured. You had to really write things out and really know the syntax and the structures and what does what. And I would say nowadays it's a lot more intuitive, it's a lot quicker to think, it's a lot more behavior driven, thinking what do you want to do, and then the code does a lot of the thinking for you, or a lot of the plumbing for you. And I would say one thing I respect and think takes a lot of effort is the backwards compatibility of the Java nowadays, especially with Java 23 all the way. And then some features and some pieces do get dropped, but there's a very long, let's say, compatibility window. Yeah, and I think that's commendable, but I think it takes a lot of thinking.
It's compatible with older versions, so you can run your old application. I guess you also went through a lot of transformations of your applications. How do you look at going from Java 8 to 11 to 17 with an existing application? Is that a joy to do?
It's not a joy, but it's not a chore. It's fairly simple. You run a couple of scripts. You fix a few minor problems where things need to be changed. That don't get changed by the scripts that you can find. And for the most part, it's actually fairly easy. Java 8 to Java 11 was way more difficult than 11 to 17. But 11 to 17 was changing a version number, recompiling and fixing one or two little things. And I expect 17 to 21 and 21 to 22 and so on to be even easier.
So the newer versions are much more stable, but bringing developer improvements and runtime improvements, right?
Yeah. I would say pre-Java 9, Java 8 was quite a step up into functional programming, as you said. But we've, at my client, still have pre-Java 8 infrastructure and legacy systems. So to upgrade them all the way to Java 21, 23 is going to be a challenge. We've decided also to upgrade some, but we said let's upgrade the platform first and then keeping the Java edition back, because that with the Java ecosystem and the libraries and the Maven and all of that, that already brings a challenge in itself. And then upgrading to a newer Java version, we don't have to change a lot, but I see a lot of people say it's an opportunity to improve your code, to remove some technical debt, to improve your system. And with that, you really have to then think of how do we change it for a better. So it's not a rewrite, but it's a hybrid kind of upgrade with rewrite. So yeah.
Support for Java 8 will end in a few years. So
They said a few years ago.
That's right. So it changed again. But still, it will end one day. So people who have a running application which are stuck to Java 8, what should they do? Do they need to move?
Absolutely. There's no doubt about it that they have to move. Either move or completely rewrite. And some companies, I guess, are taking the option of completely rewriting. Some will stick on Java 8 without support. The amount of technical debt, the amount of customization that they've done, that kind of makes it prohibitively difficult to transform from 8 to 11. If you've stuck with a vanilla Java and you haven't gone and done funny things, it's really easy. Should they move? Absolutely. The benefits in the garbage collector alone make it a worthwhile move, and the benefits that are continually being addressed actually make the proposition of going version by version as they're released into a stable version, make that a really compelling proposition. Yeah.
You agree?
Yeah, yes and no. So I would say there are benefits. As we said, it's not only new features, but the stability and the efficiency of the JVM has really improved. But for people who are really hard and fast of saying we don't have the manpower, we can't move, it's too complicated, you can stick with, let's say, a free-to-use JVM like Azul. It has commercial versions, but it's not a mandatory one. And then if you run out of support, yeah, it's a risk you gotta take.
But also remember, though, is that by not upgrading, at the same time, the further and further away that you get from Java 8, and I'm pretty sure Java 5 for a lot of people, the further away that you get from the current architecture on motherboards and chips, it's not unthinkable that we could have a different chip architecture in the next 5 to 10 years. That means that Java 8 could, in fact, be completely incompatible, even down to an architecture on the motherboard and the chip level. with the latest version of Java, which means that at some point it might actually become impossible to upgrade directly. So companies may see a step where they have to go 8, 11, 17, and then jump to whatever the new version is. So the longer they wait, the more pain they're buying themselves.
Johan Janssen, a software architect, shares some of his migration experiences and how you can convince your management that there are many benefits of upgrading your projects.
We actually did some migrations in several projects. So that was sometimes a bit of a hassle, but in the end, mostly it's quite manageable. I think the biggest discussion is always to convince management to spend some time on it. But then mostly it's quite easy to do. And nowadays you have help with tools like OpenRewrite and other tools that can assist you basically. And I actually gave a session in the past as well on how you could upgrade from one Java version to another. So I always try to stay up to date with Java versions as much as possible basically.
What do you tell to people who say, yeah, we are stuck on Java 8 because of many reasons? Can they stay there or do they really have to move?
I think it's weird, right? If you have a car, you also do maintenance and make sure that's up to date, because otherwise at one point in time it will break down, and that's probably an inconvenient time. Well, now you can plan a convenient time to do the upgrades. So normally I will also always suggest to upgrade, unless you know that your application will be removed after a year or something, then it might not be worth the investment. But if you think you will continue running it, you should upgrade it basically.
So you gave a talk about this subject. What were your advices there?
So basically my advice was that, often it's a discussion with management to convince them. It's also in your personal benefit, because if you upgrade Java, you can use all those cool new features. So you should also spend maybe some effort there. So what I did in the past, for instance, was when I did my hours for the week, I spent a few hours upgrading Java, see what broke, and then I could give a better guess at how much time I would need to fix it. And then I could say, if I have a week more, I can fix it. And then mostly you get the week. What I saw with a lot of people is they say it takes a couple of months with a couple of persons to do the upgrade. And then management, of course, says, we don't have that time. Well, in reality, I seldomly see that it's so much work.
So it's more of just try it and see what happens and then investigate.
Exactly. And now, especially with tools like OpenRewrite, you can just run it and see if everything still compiles and the tests still run. So it's even easier. And in most cases, if you're a bit up to date with your dependencies, because that's most of the work mostly, then upgrading the Java version is quite okay in most projects. So basically what OpenRewrite does is it's sort of a recipe-based tool, and they have all kinds of recipes. So for example, they have recipes to go from Java 8 to 11 or whatever version. And then what it does is it upgrades the dependencies, but it also changes the code. So for example, now we have that multi-line string. If you had the old way of declaring strings, it will automatically convert the code to the new style. And it's basically Git-based. So you basically get some Git changes, and if you don't like them, you can ignore them. If you like them, then it made your migration a lot easier. While already using all the new features in Java that you also don't need to do by hand. So it brings quite some advantages.
Again, a shout out to OpenRewrite as a handy tool to bring Java code to the latest versions. In the next podcast, you'll get the remaining JFall interviews about various topics. See you then, and thanks for listening.
Give me a foo, give me a J, give me the friends of OpenJDK.